Welcome to this series of circuit analysis techniques. So we are going to explore about the nodal analysis. Nodal analysis is one of the first systematic technique to analyze different kind of simple as well as complex circuits. So the rule of the nodal analysis is that if you have any circuit, the first thing that you should analyze is the number of nodes in the circuit. For example, if we have a look at this circuit, so we can notice that the circuit has basically total of 3 nodes. So a node is something where at least 2 branches are connecting. For example, if we have look at this circuit, so we can see that we have a current source, then we have this resistor branch, and these two are basically connected at this point, okay, which is basically called as a node. So we can label this thing as our node. And also we can notice that another resistor R2 is connected at this node. So a node is minimum intersection of connection of 2 branches. So it could be of multiple. For example, here this node, we can see that 3 branches like this current source, this resistor R1 and this resistor R2 are connected. So we should identify the nodes and then we should label it. So for example, within this circuit, okay, this node is labeled as V1. We can label this as A, B, C, D, 1, 2, 3, whatever you like. So this labeling basically help us to track the calculations, okay, the value of the voltages that we are going to find. Similarly, next if we look at the branch R2, this current source IB and this R3, okay, they are connected together at this point, okay, which is basically our second node. We label this node as V2, and then we have our third node, okay, which is basically our reference node, and reference node is typically labeled as ground, okay, because all the currents will basically flows through the reference node, and we calculate all the voltages with respect to the reference node. So after identifying, okay, the required nodes in the circuit, then we will try to write the nodal equations. So here we have seen that we have total 3 nodes, but we will write only 2 equations, 2 nodal equations. Why 2 nodal equations? Because reference node usually have a ground, and the voltage at the ground is basically 0. So we don't need to write an equation for the reference node. So here we will write the equation for the node 1, which is basically V1 here, and the node 2, which is basically V2 here. Nodal analysis help us to find all the nodal voltages. Of your circuit. Like for example, this circuit has 2 nodes, so we can find all the these voltages, nodal voltages V1 and V2 using the nodal analysis. Once we know the nodal voltages and we know the connected resistive branches, resistances, okay, for example, here the value of R1 is 12 kilo ohm, R2 and R3 are 6 kilo ohm. We can find all the currents and any other thing, for example, the power dissipation and beyond. So now let's try to write the nodal equations here. So there are multiple ways to write the nodal equations. One way is that you define a certain current flows. For example, here we can say that the current I1 is basically flowing, okay, towards the node 1, and the current I1 which is flowing through the resistor R1 is basically labeled as flowing away from the node V1. Similarly, I2 is flowing away from the node V1. And similarly for the node 2, we can say that I2 is basically coming towards the node, IB is leaving, and I3 is also leaving. So the one way is like if the circuit has like given the current direction, you may assume and use them. The other way, which is more systematic and the better way that we will use to solve all the examples of this series, what we can do, we can assume that at every node currents are basically leaving. So basically we need to write the KCL, Kirchhoff current law equations, okay, at every node to get the nodal equation of that node. So we are going to assume that all currents are leaving, okay. So for example, I assume that at this node we have three branches, so I can assume that this current IA is leaving, current through R1 is leaving, current through R2 is leaving. So basically Kirchhoff current law is that the sum of the incoming currents is equal to the sum of the outgoing currents, okay. So simply we will write this equation for every node, and we know that if we have a resistive branch, and let's say the voltage at this node is V1, voltage at this node is V2, the value of resistor is R, then the current that is flowing through this resistor I, it can be written as difference of nodal voltages, like V1, that is a voltage here, minus V2, that is a voltage here, divided by the value of the resistor. So always using this, we can write any current that is flowing through any resistive branch. So let's use this concept and try to write our first nodal equation of this circuit. So I have like already shown here. So what we can do, we can label that we are going to write the equation for the node V1. So at this node, we assume that all currents are leaving. Okay. So basically there is no incoming current. So leaving current is which one? First one is IA. So actual flow of this current is towards the node. So what we can do, we can put the negative sign to represent the outgoing current, okay, from this node. Then the next current is the current going through this resistor R1. Okay, so that will be equal to, we can put plus sign, difference of nodal voltages. So here we have voltage V1 minus, okay, the second node. So second node is ground, so V1 minus 0 divided by the value of resistor, okay, R1. Whatever the value is, okay, we know that the values are this one. We can put up the numbers later on to solve this. Next, current is going through R2. So plus, now the current through R2 is difference of nodal voltages again. So V1 minus V2, okay, second node divided by the value of resistor is equal to 0. So this is the nodal equation for our first node. Okay. Similarly, let's try to write the equation for the second node. So what we have here now, at this node, again we will assume that all currents are leaving. Okay. So for every node, every time, we will just assume that all currents are leaving from that node. So V2, like this current, leaving, this current, leaving, this current, leaving. Okay, so let's start from the current through R2. So now that current will be, again, the current is leaving. So it will be this node voltage, V2, minus this node voltage divided by the value of the resistor, plus now this current IB, again this is leaving, so we can put it same, okay, with the positive sign. The next current through the resistor R3, so that will be V2, okay, this node minus the second node. So, okay, so this is the second node which is basically connected to the ground, so that will be 0 volt. So V2 minus 0 divided by R3 is equal to incoming currents, there is no incoming current, okay, is equal to 0. So this is basically the way to write the nodal equations, and we have got the two nodal equations of our circuit. So the next, the purpose of the nodal, once we have the nodal equations, we can find basically the nodal voltages, or in other words, we can find basically the value of V1 here and the value of V2 here. For that, we need to put up the actual values of the current sources. For example, the I1 is 1 milliampere, IB is 4 milliampere, and the value of resistors. So let's put up those in these equations. So IA is 1 milliampere, so I can put 1 milliampere here, plus V1 that I need to find, minus 0 divided by R1. R1 value is 12 kilo ohm, plus V1 minus V2 divided by R2. So value of R2 and R3 is 6 kilo ohm, this is given, so I will put that is equal to 0. Similarly here in the second nodal equation, we have V2 minus V1 divided by R2. So what is the value of R2 here? 6 kilo. Plus IB value is given, that is 4 milliampere. Then V2 minus 0 divided by R3, again 6 kilo ohm is equal to 0. So this is our nodal equation with the entered values, and this is our second nodal equation with the entered values. So if you look at these two equations, so here we have two unknowns, okay, V1 and V2, okay, and two equations. So now we can use some different methods to solve two linear equations of two variables to get these values. So for that, what we can do here, okay, now just to make the further analysis simple, what we can do, we can make these equations in the more simpler form so that we can easily solve them. So for this case, now what could be the approach to make it more simple? We can multiply the whole equation with the maximum value in the denominator, okay, or basically the lowest common factor of the terms that we are getting in the denominator. So for example here we have 6k and 12k, okay, so the common factor between them is basically 12. So I can multiply this whole equation, okay, with this value of 12k just to simplify this. So here if we multiply this whole equation with 12k, so minus 1 multiply with 12, okay, what will be that? It will be minus 12. Then this is k, kilo, and this is milli, that will be cancelled out. Then we have plus v1. Now this is multiplied 12 and 12, this 12 and this 12, it will be cancelled out, so we have v1. Then plus, now 12 divided by 6k, so that will be 2, so we can put here 2 times of v1 minus v2 is equal to 0. And if we further simplify this one, so I have 2v1 and v1, so I can write this as 3v1. Then 2 times of v2 minus 2v2, and I can take the constant to the other side to get a more simplified equation of my circuit node 1. Same thing I will do at the second node equation. So again here we can multiply with 6k, okay, so let's do that. So what will be the outcome here now if we try to write it down here? So 6k divided, so I have v2 minus v1. Then 4 times 6, that will be 24. Again k and milli will be cancelled. Then we have v2, and 6 will be cancelled, is equal to 0. So if we just simplify this one, rearrange it, okay, so it will be minus v1. So v2 and v2, we have 2 times of v2 is equal to minus 24. Okay, so that will be my second nodal equation. So once we have obtained these forms of the equation, so we can use them for our further analysis. So the purpose of solving this equation is that will help us to get the value of the voltages. Okay, so now let's try to simplify these two equations for our further analysis, that how we can get the actual desired voltages across the nodes of our circuit. So I'm going to use these final forms of the circuits. So let me just rewrite them here. So we have basically 3v1 here. Okay, so I have 3v1 minus 2 times of v2 is equal to 12. Okay, this is my first nodal equation, and the second one is minus v1 plus 2v2 is equal to minus 24. Okay, so this is basically equation 1, and this is my equation 2. Now let's see how we can basically simplify these two equations. We can solve these two equations basically to get the value of v1 and v2. So again, there are different ways, okay, to solve such equations. We can use the simple linear algebra, we can use the Gaussian elimination, okay, that we can write them in the form of the matrix form, and then we use a matrix analysis, okay, to get the A inverse, and then we can find the values, or you can simply use your scientific calculators, okay, write these two equations, and then we can find the variables value. So I will just do this example with the simplest method, okay, of substitution. So what we can do in the substitution, we can take the one variable value and we can put it in the other equation. For example, from this equation, I can say that basically 3v1 is equal to 12 plus 2 times of v2, or v1, okay, we can divide with 3 on the both sides, so we'll have 4 plus 2 over 3 of v2. Now let's substitute this one to the second equation. So we will get the basically one variable value from the first equation, and then we substitute in the second one. So v1 is 4 plus 2 over 3 v2. So let's substitute. So we have minus v1 here, so that will become minus 4 minus 2 over 3 times v2. Then we have plus 2v2 is equal to minus 24. Now here we have a simple linear equation, okay. With one variable, we can simplify this to get our desired answer. So here minus 2 over 3 plus 2. What will be that? So that will be basically, we have minus 2 over 3, okay, and plus 2. So that will give me 1.33 v2, and this minus 4 will go to the other side. So minus 24 plus 4, that will be minus 20. So if we further simplify this one, that will give us a value of v2 here, okay. So v2 is basically 20 divided by 1.33, that comes out to be 15.03 volt, okay. So approximately 15 volt, okay, minus 15 actually, because of the negative sign. So once we have this value, we can plug in, okay, in the equation, this substitution equation, so that we can get the value of v1. So let's plug this here. So v1 basically will be what? 4 plus 2 over 3 times v2. v2 is basically minus 15.03, okay, if you want to get the exact number. So what will be that? 4 plus 2 over 3 times minus 15. So answer comes out to be basically minus 5.9, okay. Or like if we go to the exact, so we can say that this is around minus 6. So with this nodal analysis, okay, we found the values of v1 and v2, okay. So value of v1 comes out to be minus 6, and value of v2 comes out to be minus 15. So this way, by writing the nodal equations, doing the simplification, and then just finding the variables value, we are able to find the values of nodal voltages v1 and v2 for this circuit. Thank you so much.